This video is sponsored by Brilliant. So I just got this question from one of my viewers. It says, "Teacher, could you please explain why this function, its inverse happens to be its derivative?" This is a very interesting question. Let's have a look. What we are trying to do is solve this functional equation. And the comment gave me the answer, which is this. And right here, let me just make a note that phi is the golden ratio, 1 plus square root of 5 over 2. And another note is, if you have a minus in between, this will also work. Now, how do we solve a functional equation? Let me tell you, it's not easy in general. So what we are trying to do first is, we'll try to guess a form for the answer and hope it works. If it doesn't, try another one. If it doesn't, maybe try another one, or maybe try to prove it doesn't have an answer or something like that. So let me just show you guys what we can try first. Let's try an easy one first. Of course, if you're dealing with the derivative and the inverse, a power function is a good choice to start with. So suppose our function is in the form of x to some power, let's say b. Well, its inverse is just going to be x to the 1 over b's power. Why? For example, if you have x to the third power, then the inverse is the cube root of x, which is just x to the 1/3 power. Now, for the derivative, you use the power rule. So we will have bx to the b minus 1. Now, we are going to make them equal to each other. So x to the 1 over b's power, hopefully is equal to x to the b minus 1 power. But unfortunately, this is not going to work. Because in order for the left-hand side to be the same as the right-hand side, the coefficients must be equal to each other. So that suggests us that, since this is 1 in front of the x to the 1 over b, it suggests us that b has to be 1. But does that work? No. Because if b is equal to 1, put this here, we get x to the first power. Put this here, we get x to the 0th power. So no, it's not going to work. So what do we do? Well, don't worry. Let's try to fix it a little bit by putting a coefficient here. So maybe we have a better chance. So now let's have a look. So before we continue, let me tell you about our sponsor today, Brilliant.work. Brilliant is an online learning platform that helps you to get smarter every day with thousands of interactive lessons in math, science, programming, and more. What I love most is how it forces you to think. You are not just passive reading or watching, you are solving real problems step by step, and that's how real learning should be. Personally, I like Brilliant because it reminds me how I learned math growing up, by playing around with ideas and struggling a little until I really got it. It's that kind of hands-on thinking that helped me become a better problem solver, and I see the same effect when I recommend it to my students. And if you're working on algebra or calculus, their courses are especially strong. Everything is built up to help you really understand. Go ahead and visit the link brilliant.work/blackpenredpen or scan the QR code on screen, or you can also click on the link in the description. When you do that, you will get 20% off an annual premium subscription, so go ahead and check them out. Okay, here we go. Let's try. And you know this is going to work for this time because we have the answer right here already. But anyways, let's say we have a coefficient a and then x to the b's power. Now, here's a quick way to get the inverse for such a function. Originally, what we do first is we do x raised to the b's power, and then we multiply by a. To get the inverse, you start with x. You first want to divide the a. And of course, a cannot be 0 because otherwise you cannot have an inverse. And then you are going to do the reciprocal power, which is 1 over b's power. So that's the inverse, and for the derivative, of course, it's just the power rule. So ab x to the b minus 1 power. And again, a little note is that a is not equal to 0. Now, this has to be equal to that. So here's the deal. We have a on the bottom. This is the same as a to the negative 1 power, and then raise that to the 1 over b's power, negative 1 times 1 over b. So this right here becomes a raised to the negative 1 over b's power, and we also have x to the 1 over b's power. So x to the 1 over b. Then we have this. AB x to the b minus 1. Now, we have to have two conditions. The coefficients must be equal and the exponents must be equal. And since the exponents are just with b, so let's tackle that first. Condition 1, 1 over b has to be b minus 1. And now we can solve this pretty easily. Multiply everybody by b, so this is 1 equals b squared minus b, subtract 1 to both sides. And then use the quadratic formula. Negative negative 1, which is 1, plus or minus square root. Negative 1 squared, which is 1, minus 4 times 1 and negative 1, so 1 minus negative 4, which is 1 plus 4, which is 5, and all over 2 times 1. Have a look. This is the golden ratio. And also, if you use a negative right here, the following will also work. Very nice. Now, secondly, we must have the coefficients equal to each other. So, a to the negative 1 over b's power has to be the same as ab. And by the way, b cannot be equal to 0. It should be pretty clear. Yeah, but anyways. Now, to solve for this, a is not 0. This is where we have to mention that, but the rest should be okay. Divide both sides by a. Rule of exponent says that we will just do the top exponent minus the bottom one. So this becomes a raised to the negative 1 over b minus 1. Now, as long as we can solve for a, then we'll be done, right? And this is how I'm going to do it. Right here, I would like to factor out a negative. So that's 1 over b plus 1. And before I do anything, I just want to tell you, because they are related, this thing right here, you can look back to here. Have a look. 1 over b is equal to b minus 1. So from here, I can add 1 to both sides. That suggests us that 1 over b plus 1 is just b. Very nice, huh? And in fact, that's one of the properties for the golden ratio as well. So this becomes just b. So we are going to get a to the negative b's power. That's equal to b right here. Now to solve for a, we just do the reciprocal power to both sides. So raise both sides to the negative 1 over b's power, like so. So they cancel. Now we get a is equal to this, b raised to the negative 1 over b's power, just like that. Yeah? And of course, you can just put this number in here and work out. That's pretty much it. However, though, I want to end up with this answer for you guys. So we'll continue just a little bit more. But before I do anything, though, I'm going to utilize that equation again. Because notice that we have negative 1 over b. I can look at this right here. I'm going to move this to the right-hand side and then put the b to the left-hand side. So this right here, once again, will give us negative 1 over b being equal to 1 minus b. You will see why I do that. So this is the same as b to the 1 minus b. Okay, they are the same. Now, ladies and gentlemen, here's how I'm going to finish the rest. Take b equal to phi, which is the golden ratio. Let's just do this version. And you will see that a is just going to be phi raised to the 1 minus phi's power. Now, our function, it's going to be a times x to the b's power. A is this. Now, what can we do? I can write this as phi to the first power over phi to the phi's power. And then we multiply by x to the b's power, which is phi, like that. Notice that both of this, they have phi's power, so I can do the following. F of x equals phi to the first in the front, and then rewrite that as x over phi raised to the phi's power. And that is the answer that we have here. Very, very cool. Yep. And yeah, that's pretty much it. Of course, the following question is that do we have any other functions or any other types of function that will make this work as well? To my knowledge, I don't think so. You can try the other ones, such as you can start with a general form of exponential function, maybe like say b to the x power instead. If it works, good. If it doesn't, maybe add a coefficient, etc., etc. And if you feel adventurous, you can try with like sine, cosine, and just leave a comment down below and let me know if it works or not. I don't think so though. But anyways, that's it.